Thank you all for joining this BNO speaker pattern webinar. Now, before we start, let me introduce myself. I'm Aman. I'm an industrial designer, and I use Rhino and Grasshopper as my primary CAD tool. And I use Rhino and Grasshopper to, create 3D files, especially textures. And I help design teams make these textures manufacturable. Okay. Apart from that, I am also a co-founder at Academy with my colleague Estella. She's also in the chat. She will be answering some of your questions. And we train industrial designer across the world, design students, professionals, and studios with Rhino and Grasshopper. We provide live training for you and your team. Okay, you can check our webpage. It's academy.xyz. Apart from that, you can also follow us on our social media. So at Creative Mutation is mine, personal, and at academy.xyz is the academy. Okay, this is where you will see a lot of learning resources that we can keep on adding for you to get better at Rhino and Grasshopper. What can you learn at Academy? So we have these 5 courses, and we provide these courses on the weekend. Okay, and I'll tell you more about these courses later on as we progress through different exercises. So let's make sure we have all downloaded the files. Okay, so you will see these 6 different files. Okay, one is Rhino, then we have 2 Grasshopper files, a Keyshot file to test, and some materials, and then the final Keyshot rendering file. All right. Now, this is the main problem that we are facing. We want to recreate this texture, all right, first in Rhino, the CAD model, and then apply the texture using Grasshopper. The problem is we cannot create these perforation textures manually. That's impractical, right? We have more than 3,000 perforations, and creating it one by one is not practical. We might use some kind of like array in Rhino, but the problem is we cannot tweak these values. In this case, the circle size goes from small to large as you go outside in the radius. All right, so that is something we cannot do easily in Rhino. Apart from that, you might want to use some AI tool to write codes for Python script. While you can get this kind of parametric effect, like a fading effect of the radius size, it's very difficult to tweak these values, okay, and see the effect in real time. All right. So let's start to recreate the CAD model first in Rhino. Okay, so we will start by creating the 2D curves, and then we will revolve to create the base geometry. Then we will have the base perforations from the backside and the vent holes. So we'll cut that out. We will create the revolved legs, and then we will orient it along the backside. We will add the vent holes. Okay, and then we will use Grasshopper to apply the texture. All right, so go ahead and open Rhinoceros. Okay, so I'm using Rhino 8. Some of you might be using Rhino in Mac. So it's basically the same. All right, so if you have any questions, if you cannot find a specific command, let me know in the chat and I'll point it to you where you can find in Mac or Windows. All right. All right, so meanwhile you are opening your Rhino environment, let me quickly explain you about our Rhinoceros 3D Masterclass. Okay, so this course is ideal for beginners or intermediate users. So beginners or intermediate user basically means that you have never used Rhino, for example, or you have used Rhino, but you don't really understand what is a degree 3 curve, what are NURBS geometries, what is solid modeling, what is surface modeling. Okay, so this course is good for someone who's basically starting with Rhino, or they have some questions about fundamentals. Okay, so here you will start with basic 2D drawing, and then we will slowly create CAD models for solid modeling, like Boolean operations. Then we will see NURBS and in curve and surface topology. Then we will be learning how to create simple class A models, mesh and sub-D models, okay? These are some of the projects from our students who have done the Rhinoceros masterclass in the past. All right, so let's get back to the exercise. So I'm going to drag and drop the first Rhino file in the Rhino environment, okay? So let's select the first file, drag and drop it here, and open the file. You can also double click on the file to launch Rhino and open the Rhino file. I'll wait for you a sec. All right. Now, if you have joined one of our past webinars, you know that we have all the steps in the layer tab. Okay, so go to layers and you can now see all the different steps to construct this geometry. All right, so let's get started by making the base curves. All right, so I have already made a curve for you here, and this curve has a radius of 630 millimeters. Now let me show you how can you make this front curve that has a radius of 1078 millimeters. Okay, for this I will recommend you to go to the top, front, or the right viewport. Okay, so let's head to the right viewport and let's zoom in to this area. Okay, now you can increase the size of these annotations. Let me make it a bit bigger so it's easy for you to see. All right, and now let's say how can we make this arc between point A, point B with the radius of 1078. For this, we will be using an arc tool. Okay, now within the arc tool, there are sub commands, and the command that we are going to use is called starting and radius, this one. Okay, start and radius. So start of the arc is this point, end of the arc is this point, and the radius is 1078. Press enter. Now you just have to define the angle, like this side or the other side, in this case right side, and there we have the base curves. Okay, all right, I'm using power tray, I think it's called, for highlighting areas using the mouse. Now once you have made this curve, you can unhide the next layer called curve finished. Okay, to make the finished curve, you basically need to take these curves and offset them, curve offset. And I have also defined the amount of offset, 3.5 here and 3.5 here. Okay, you can join the curves and then apply fillet between them. Okay, so these are very basic operations. Let's say a radius of 1.5 on both sides. So this way we can make the base curves. All right, so let's unhide the next layer, curve finished. And you can hide the previous layer. Let me delete the curves that I made. All right, perfect. So once we have unlocked the curve finish layer, now let's see how can we create the 3D revolved shape. So go ahead and maximize the perspective viewport. And in this case, we will be using surface creation tool called revolve. Okay, so let's revolve these three profiles. Select profile A, B, and C. Press enter. Then define the axis, which is this line. And then you can click and then click to define how much you want to revolve. Okay, but in this case, we want to revolve completely. So let me undo and redo the command revolve these three profiles from here till here. And there's this button called full circle. So it will revolve 360 degrees automatically. All right. So now we have the three revolved shapes: the back side, the front side, and the metallic rim in between. Okay. So let me undo these steps. I have already provided you these geometries in the revolve layer. Perfect. Now, let's say, how can we add these perforations cutouts? Okay, so go ahead and unhide the layer cutout. And here you can see we need to make some ellipses. Okay, for that, you can go to the front viewport. So it's easy for you to draw the curves. Okay, front viewport. And now let's create some ellipses. So you can use the ellipse tool, not the circle tool, okay? Because in circle tool, you can only draw the starting point and the radius. Whereas in the ellipse tool, you can draw the starting point, the end point, and the second radius. Okay, so using the ellipse tool, let's use these green marking points for each of these curves. Let me increase the dimensions. It's easy for you to see what is going on. Okay, so the second ellipse is made from this point to this point and then to this point. And the last one is this one. Okay, so these are the three curves that I have already made for you. You can delete the curves. And we will make a very small offset, maybe 0.5 millimeters, just to create a gap tolerance between the cut shape and the inner cap. Okay, so these are the curves that we need to create the cutout geometry. No, contour will not be an ideal solution in this case because the geometry is not exactly concentric. Okay, so this is a better strategy. All right, so how do you cut this geometry? First, you need to head to the perspective viewport and select, let's say, one of this curve. I'll first show you using a single curve. Now, when you select a geometry, you will notice this tool. This is called the gumball in Rhino. If you don't see this tool, you have to enable it here. Okay, gumball. Now, the gumball has an arrow which you can use to move a geometry. It has a circular handle that you can use to extrude a geometry. However, it also has the line kind of like a handle. And if you click on it and drag using the line handle, you can actually cut a geometry. Okay, so this way we don't need to extrude and do Boolean operations. In Rhino 8, they have introduced push and pull options. This is one of those. So you can select all the curves and use the line handle to cut out the different parts. So now you will notice that I have the tap here, the intermediate part, and then the perforations that we need for subwoofer. Okay, so this is the cable inlet, this is the part where the legs will be attached, and this will be the subwoofer vent part. All right, so I've already done these operations for you. Apart from that, we also have a handle on the back side. So in order to make the handle, you need to make these curves. Okay, it's very easy to make. You have to use two concentric circles and then you create a blend curve between them. You create an offset curve. Okay, and let me loft these two shapes. Okay, and you can also cap it to make it into a solid model. So this is what you see here. Now we want to keep the inner part and remove the outer part. So the easiest way to do this is using Boolean difference. Remove material from here using this. Okay, and we can get rid of this part. You need to also remember that in all of our files, we maintain a uniform distance between the objects so that you can copy and reposition the object exactly in the correct place. For example, in this case, we can move this object by 500 and 1000 units. Okay, so you can use Control C, Control V, and then 1000 units in the x-axis to reposition the geometry exactly in the same place. Now I can join these two solids, Boolean union, and I can use the offset curve that I made earlier to cut out a hole. Okay, so if you use a line handle, you can cut out a hole. Now in this case, we don't want to go all the way through. Okay, we want to stop before we reach the end wall. So what you can do is go to the top viewport, and you can then draw the handle up until here, more or less. You can also measure the distance, okay, to use a precise number. All right, so once we have the final model, okay, you can see here the solid body. You will also notice that in some of these models, I have the ISO curves visible. That is the default behavior of Rhino. But if you want to hide it, you have the option to hide the ISO curve independently for each object by enabling this option in the Properties tab. Okay, perfect. So now let's go to the next step, which is how can we add the legs? All right, go to Layers, and then unhide layer 5, tripod legs. Okay, let's go to the front viewport. Okay, anytime you are having difficulty in zooming into a specific area in Rhino, select the object, and then there is this option called Zoom Selected. Okay, you can click on this button, and it will center the object on your camera. Again, zoom to the object. So it's easy for you to move the camera around that object. Anyways, so let's go to the front viewport, zoom selected. Now, in this case, we have drawn a cross-section profile. Now, I'm not showing you how to draw these profiles. It's just a basic set of curves. Apply some fillet. And then you have the central axis. Same with this part. Okay. Now, let's go back to perspective mode. And we just need to revolve this profile around this geometry. Okay, so let's reuse the revolve tool, surface creation, revolve, object to revolve, the central axis. Now, instead of clicking from one place to the other, we want to revolve it completely. So click on full circle. Okay, now when you revolve the geometry will be open, so you can easily make it a closed geometry by running the cap command. Okay, so in Solid Tools, you have this cap holes command. Okay, so let's click on that. You can also run the command using the command bar. Okay, so first revolve, full circle, and then run cap. Okay, so these two are the solid models. And we can also hide the ISO curves if you don't want to see the additional internal curves. Now, once we have revolved the profiles and capped the geometry, now we need to orient the legs around these three curves. Okay, so I have calibrated the curves to more or less mimic the position of the legs in the original model. So in order to orient this part here, you can use the orient command in Rhino. Okay, so let's go to command bar and write orient. Anytime you have difficulty in understanding how to use a specific command, you can go to the help menu. Okay, and anytime you run the command, this section dynamically updates. Okay, so you can see what is the command name, where you can find it, and how to use that specific command. So let's say if I ran the revolve command, it will automatically update, and it will also show me how to use that command. Okay, so in this case, let's rerun the orient command. Okay, select the object to orient. Let's start with this one. Press enter. Now we need the first reference point. So the first reference point is the centroid, or this point that I have made. And then the second reference point is the end of the geometry here. Okay, so once we have defined the 2 points, let me redo it, sorry. first reference point, and second reference point. Now it will automatically ask me to select the first target point, which is this one, and then the second target point. I mean, you can click anywhere along the axis and it will automatically orient the part. Okay, so that is there. By default, the orient command, there is an option called copy. So if you want to maintain the original geometry, you can set it to yes. Starting point, second reference point. Similarly, starting point, second target point. Okay. The angle you don't need to define for orientation. That is the benefit of using this tool. You just need a starting point and an end point, and then it will automatically orient the part. Of course, if you want to rotate it later on, you have to rearrange the gumball and align it there. You have to rotate the gumball and then you can rotate the object. Okay. You can also use custom planes to do that. Now, let's say you want to mirror this object on the other side. So let's run mirror and then mirror it on the opposite side. All right, perfect. Now, once we have arranged the parts, we need to also make holes for these legs to go inside of the model. Okay. So I have calibrated the holes by basically measuring the radius and adding a bit of offset. So you just need to convert these 3 lines into pipes, and the radius is defined here. So let's run the pipe command. Pipe, select this curve, and the radius is 20 and 20. Okay, there we go. Same thing here. And this one is 21.5. Okay, so I have already made these geometries for you. And now you can run Boolean difference. So object to remove the material from, object to remove the material with. Okay, so now we have the holes on the intermediate part. So if I move the legs by 2000 units, you can see it exactly fits the holes. All right. Let me know if you have any questions up until this point in the chat. Now let me go to the next layer, vents. Okay. Now in this case, you have the 2 points, just like earlier, to make the ellipses. Point A, point B, point C. Same thing, point A, point B, point C. Okay. Now, in this case, I'm using another Grasshopper script to make the pattern, and it's a bit more advanced workflow. Okay. So once you have made the curves in Grasshopper, I will bake the curves. All right. And then we can combine these geometries as a single closed curve using a command called curve boolean. Okay, so in Rhino, there is a command that you can use when you want to fuse multiple curves together as a single geometry. Let me show you how you can use it. So we have curve tools, curve boolean. Okay, select all regions, and it automatically combines them together. Okay, perfect. Some of you are asking me why not use the circular handle or line handle to create these cutout shapes. The problem with that approach, I mean, it can work. The problem with that approach is that you need to rearrange the gumball and make it normal to this geometry. And for that, you can use the custom plane options. You need to make a surface and go to C plane and align the object to the C plane, and then use that to cut the geometry In this case, it's not intersecting, I think, properly. Yeah, it's not intersecting properly. Anyways, and then you have to reset the gumball. So it was easier for me to just convert these into pipes and then perform Boolean difference. Okay, again, remember in Rhino, to do the same operation, you have, or to get the same geometry, you have different pathways. Okay, in this case, this one was the easiest for me. All right, so once you have these curves, let me show you how you can combine them into closed curves. Just select the curves and run curve Boolean. And then use the all region option and press enter. So you can now see it has combined all of these intersecting curves into a single closed curve. Anyway, so once this is done, I'm always moving these geometries by 500 units. Okay, we can go back to the perspective mode, and same thing, we can cut this geometry using the line handle, extrude, and we have the cutout shapes. Okay, there we go. Okay, so this is the final output. We have the base vent, we have the leg input. Now we need to create a shape here to get the cable inlet part. So let's unhide layer 7. Just intersecting, someone is asking, how did you calculate the radius since the legs taper? What you can do in this case is just use the geometry here, okay? And then you can intersect or like evaluate the radius in this cross section. Okay, radius by extracting the isocurves. And then you can measure the radius, and then you can see how much the value is and just offset that slightly to get the desired whole amount. Okay, so this is how I can calculate the correct radius value. Anyways, so let's unhide the cable outlet layer. Okay, so this is the solid part that we started with. Okay, this section. Now I will explode it to remove all the excess parts, so the front face and the lateral face, and I'll isolate just this backside as a single surface. Okay, now this geometry has been trimmed from the entire back panel. Okay, so if I turn on the control points, you can see this is the original geometry from where we cut out that shape. Now there is a command in Rhino which limits the excess trimmed part in a geometry. Okay, let me show you what it does. So imagine if you had a surface and then you create a cutout shape there. Okay. Now, if I delete the excess part, you can see this surface has been trimmed from the original geometry. So I can always untrim it back to the original boundary. Okay, the same thing you can see here. If I show you the control points, I can untrim this geometry back to the original boundary. All right. Now, in this case, let's say I don't want the untrimmed part to go all the way till this original boundary. I can trim the surface on its isocurves. Okay, so what we can do is limit this phantom part of the surface. It's easy for me to manipulate the geometry locally. All right, so what you do is there is a command called shrink. Wait, it's called shrink trimmed surface. You can find it here in surface tool, shrink trimmed surface. So what it does is it reduces that phantom access part to a more localized set of surface. Okay, it's the same thing that you would do if you split a surface using isocurves. Okay, so imagine if you split a surface using isocurve. Okay, now we have the section here where we had the surface. Okay, the circular cutout shape. So by running this command, we limit the overall extension of that trimmed surface. So we can do the same thing here. Let's select our surface, turn on the control points. Okay, if you run the command shrink trimmed surface, it will reduce the access part. Now, if I select one of the points and I move it, you can see it's changing the shape of the entire geometry. Now, if that is the design intent, sure, we can leave it as it is. But let's say in this case, we want to have a bit more local control. So I can split this geometry on one of the isocurves on the opposite direction around here. Okay, rerun the shrink to trimmed surface, and then I can modify the control point. So we now have a localized effect. Okay, so you can try it here. I have already trimmed, shrunk the surface, and also trimmed it on isocurve. Now, if you select the control point, you can move it backside, or you can also move it downside like this. Okay, so you can see the object from the front viewport and modify it as per requirement. Okay. Once this is done, you can run a command in Rhino called emap, and this is gonna show you the object with a HDRI highlight. Okay, so this is gonna help you understand the quality of surface. Okay, it's called emap. All right. Now the last step is to select the objects and extrude it. Now in this case, let's extrude them by -1 millimeter. So using the circular handle, you can extrude the object -1 or -2, and then you can join the two shapes together with Boolean union. So that is the final part. So these are all the three shapes on the back side. You can run emap to see the end result. And you can also assemble this outer part by moving it with 13,000 units. Okay, this is the advantage of spacing the objects with fixed distance. Now I can align them easily without using any specific command. Lastly, if you want to add micro fillets, you can go to fillet tool and maybe add a millimeter or 0.5 millimeter fillet on all of these edges. Okay, to create a better visual output. Anyways, so once this is all done, we will move to the next phase, which is creating the pattern in Grasshopper. Now, before we go there, let me know if you have any more questions while I look at some of your questions from the past. Sure, the angle defined for orient. Yes, that is easy. You just use it starting an endpoint. I have also explained the why don't we use the handle instead of Boolean difference. Since I have a 3D space mouse. Sure, I have used it. I had one. I didn't find it useful in my personal use case because I use mostly Grasshopper, and in there I'm moving in a 2D, like, canvas. And apart from that, if you have configured your mouse properly in Rhino, you don't generally need the 3D mouse. But anyways, if you find it useful, of course, it's a good tool. How did you calculate the radius? Okay, is Rhino good for drone or airspace design? Sure, yeah, you can make some decent surface models in Rhino. There are certain drawbacks in Rhino compared to other primarily surface CAD modeling tools like Alias, right? So there will be specific steps that, for example, in Alias, you can do it in one command, whereas in Rhino, you have to do the same steps in 3 or 4 commands, okay? And if this is a step that you need to do again and again, it can compound, which in some techniques of class A model is the case. So depending on what are your requirements for making this high quality surface model, I would encourage you to either use Rhino or maybe learn Alias for that. But generally speaking, for ideation, for 3D printing, for portfolio, for testing out the designs, and for even for manufacturing, Rhino is great. It's just that if that product is very premium product, you need a lot of aerodynamic simulation, and you want to make a high quality surface model, Alias will be a better option. Anyways, perfect. All right, so now let's head to the next section, which is making the pattern in Grasshopper. Okay, now for this, make sure like we are not around the end of the timeline of this 3D model, rather at the start, okay, where we had our initial set of curves. Okay, so maybe select the objects around the starting point and zoom selected. Okay. You can hide all the previous steps and unhide this layer called image. Okay, so I have made a 2D image that we can use as a reference to create the pattern. All right, now the next step is using Grasshopper to make the pattern. So this is one of our other foundation course, ideal for intermediate and beginner users. So imagine if you have never used Grasshopper, or if you have used Grasshopper, but you really don't understand what is graphed, what is flatten, how to manage lists and data tree, how to construct geometry, how to deconstruct geometry, you will learn those concepts in this course. Okay, so here you will start from the scratch. I'll explain you what is a component, what are data types, then we will make simple parametric models, we will see attractor workflows, and then we will combine it all with a texture exercise. Okay, these are some of the projects from our past students from the Grasshopper 3D Master class. Anyways, so now let's see how can we make this texture in Grasshopper. In the posts that we shared on LinkedIn and Instagram, you might have seen the word Fibonacci sequence or Fibonacci texture that is used in this particular case. Well, it's sort of Fibonacci texture. Okay, I'll first show you how to make it as a Fibonacci sequence, and then we will use a different variation of it. So basically, it's a very simple workflow. You start by making, let's say, a circle, and then you take a point on the circle, let's say at 0 degrees. Then you rotate that point by the golden angle, which is 137.5 degrees. Okay, so you take a point and you rotate it by this amount. And you keep on repeating this process for the next set of circle. So another circle, which is slightly bigger, you will move the point by 137.5 and again 137.5, so 2 times. And in the third circle, you will move it by 3 times. In the fourth circle, you will move it by 4 times. Okay, so if you keep on doing that, so here, let's say the second circle, you take the point and you rotate it by 137 and then again 137. So you rotated it by 2 times. In the third circle, you will rotate it by 3 times. So 1, 2, 3. And then you keep on doing that again and again. Okay, and if you keep on doing that, you will see this Fibonacci sequence. All right, so let me show you how can you make this pattern in Grasshopper. So to launch Grasshopper, you have to either go to the command bar and write Grasshopper or click on this green icon. Okay, it's going to take a couple of seconds and it's going to show you this floating window on top of your Rhino environment. Okay, generally you will use half of the screen for Rhino and the other half for a Grasshopper. So let me dock it to the right side of the screen. Okay, another thing that I generally do is I expand the panel all the way till here so that we don't have any parts of my Rhino window hidden behind the Grasshopper interface. Anyways, so once we have this, you can just make a new file in Grasshopper. And let's see how can we recreate a Fibonacci texture. For that, let's go to the top viewport. It's easy for us to see what is going on. Just be careful. Make sure you're around the center of Rhino. Okay, to see the 2D pattern. You can also hide the other layers. Perfect. So now let's see how can we make this pattern. So in order to make this pattern, let's start by making a circle. Okay, so you can double click and write circle and use this particular component. You can also go to curves, primitive, and make a circle. Okay, so the circle that we need to make here, the first one will be around 34 millimeter radius. So double click and write the number 34 and enter. So this is going to make a slider with that number. As you can see, this is the inner radius of the pattern. And the other circle we will make is around 312 units. Okay. This is for the limit of the pattern, not the limit of the geometry. So we need to make a circle with 34 and 312. Now we need to make a couple of more circles in between of these two circles. Okay, so what I can do is create a set of numbers, a range of numbers between 34 and 312. If you want to disconnect a cable that you have already connected in Grasshopper, you can either right click on the radius input, go to disconnect, and then click on the cable that you want to disconnect. Or you can press and hold Control on Windows. You can see the arrow turns red in color, and now you can disconnect it. Or you can press and hold Option in Mac. Okay, I think it's Option or Command. Okay, it's one or the other. All right, so now let's see. We need to make a range of numbers. So there is a command in the Sets tab, sequence range of numbers. Okay, so in order to create a range of number between 34 and 312, we need to create a domain between these two numbers. Okay, to construct this domain, go to Maths, Domain, and then look at the first component, construct domain, and we will use this component. This is the starting number, this is the end number. Okay, and you can see here we created a domain 34 from to 312. Now let's connect to the domain input. Okay. So if I show you the output, it's making a range of numbers between 34 and 312 and any number of steps we want in between. So let's connect that to the radius input. Okay. And you can see now we have 10 curves starting from starting from 34, ending at 312. So these are the circles. Now let's make a point on the starting point of the circle. So there is a command called point on curve. You can find it here, curve analysis, point on curve. Okay, always read the name that you see on top of the component, and you can double click and write the same text and you will find the same component. Okay, all right, so let's connect it here, and you will notice that at the moment it's making the points at 50% of the curve. We want to make it at the starting, so just move the dial to the left side. We want to make the point at the starting point of each circle. Okay, so far pretty straightforward. Now, as I told you in this explanation, we need to make a radius of, an angle of 137.50 degrees. And then we need to keep on making twice of that amount, thrice of that amount in each step. Okay. So what we need to do is create the number 137.50. So double click and create a number slider. In this case, yeah, we can use series as well, but when you know the starting number, when you know the end number, generally you use a range. We will now use the series component, as you will see. So in this next part, we want to rotate this point by 137 degree, the next one by 137 times 2, the third one by 137 times 3, and so on. Okay, so what I can do is create a series of numbers. So you can find the series component at sets, sequence, series. Okay, so this is the starting number is 0. The first point will not be rotated. The second point will be rotated 137 degrees and so on. So don't connect anything to the start point. Okay, by default, it's creating 10 copies of the number. And you can see in each increment, we have 0, 137, 275, and so on. Okay. Then you will use the rotate component. You can find in transform, Euclidean, rotate. Okay, this one. You want to rotate these points. Okay. And we want to rotate by these amount of degrees. The problem in Grasshopper is that the values are actually provided in radians and not in degrees by default. Okay, so we need to convert these degrees into radians. There is a command called radians where you convert these degrees into equivalent radians, and we connect it there. Okay, and there we go. Now we have a Fibonacci sequence. In order to properly see it, hide the other nodes. Okay, so to hide other nodes in Grasshopper, you select the nodes that you want to hide. You press the middle mouse button, and there's this option to enable or disable the preview. Okay, on Mac, you can also press, I think, Option space together, and that is also going to launch this radial menu, and you can enable or disable the preview. Now you will say, this doesn't look like the Fibonacci sequence. Well, it's true because we don't have sufficient points, okay? But let's say if you connect a number slider, for example, 200 units in the step count, okay, here, and the count input here. Now you can see we are making more circles and we are creating more values to rotate the consecutive circles or points with that radius amount. Okay, so as you increase the slider, you can see the Fibonacci texture. Okay, and this is one of the advantage of using an approach where we have a starting number and the end number, so we can control where the Fibonacci sequence starts and where it ends, especially as we want to make textures on products. Okay, it's not just a pure mathematical texture, but we want to apply it on a design, so we have to play with the constraints of the design. Okay, let me know if you have any questions. If you were unable to follow this part, you can write your questions on the chat. Now, this is great. The problem with this approach is that as I was looking at the pattern from close by, we needed a lot of points on the innermost circle. Okay. And in order to do that, I was probably using 10,000 points. And even then, I was not able to get the desired result. Or maybe let's say we are able to get the desired set of points there, but you can notice on the outside, the pattern no longer makes sense. It doesn't correlate with the perforation texture. So this is why I mentioned you earlier that it's kind of the correct solution. Okay, it looks like a Fibonacci sequence. It is inspired by it, but there is a bit of manual tweaking going on here. All right, so I'll show you how can we make it from scratch, the correct one. Okay, this one. Yeah, so let me answer some of the questions. How did we hide the components? So no worries, select the component that you want to hide, middle mouse button, enable or disable the preview. Okay, you can also see how a component that is disabled look. So in this case, the preview is disabled, whereas in this case, the preview is enabled. So you can see this is gray and this is white. So you can differentiate which component is enabled or disabled. The preview, I mean. Be careful you don't disable the component that is turning off the component and not just the preview, okay? All right. So this way you can make a simple Fibonacci texture. And again, you can use this script to make different patterns for your projects. But the one that we will use is slightly different. Okay, so let's see how we can make another variation of this pattern. Okay, so we will be using the same numbers that you see here, at least until the circle part. Okay, you can delete the rest of the things until here. Okay, so we are still starting with 34. We are still going all the way till 312. We are creating a set of, let's say, 10 circles like before. Now, what we will do is use a tool called evaluate curve. Okay, you can find this command here in curve analysis, and here you have evaluate curve, just next to the point on curve component that we used in the last part. Okay, now this component takes in a curve. Let me show you what it does. It takes in a curve, it takes in a numerical parameter, okay, and it gives you a point on the curve. The problem is, by default, this curve numerical parameter called domain would be between two random numbers. Okay, 0 to 1000, in this case 62. It's basically the length of the control polygon. But yeah, that's not relevant here. So what you can do is convert this curve, instead of this 0 to a random number, you can convert it from 0 to 1. So it's easy for us to make a point anywhere on the curve. To do that, you need to right click on the curve input, and there's an option called reparametrize. So what it does is it converts the curve, instead of 0 to the random number, 0 to 1. So now at 0 you can see the starting point, and at 1 you can see the end point and everything in between. Okay, so we'll use the same tool with our circle component output. So we have these 10 circles. If I connect these circles here, I can make points on the circle. Okay, anywhere on the circle. So the first point, I will make it at 0. The next point, I will make it at certain higher number. Okay, and I can keep on doing that so that I get the same pattern that you see here. Okay, so to do that automatically, let's make another range component. And we need to use the rotation amount here. So let's say I will use the number 0.001. 163. Okay, I have calibrated it, but you can see how it affects the pattern. Okay. And now let me connect it here. So you can notice how the pattern looks. Okay, as it follows the shape. So I will use 0.163. Sorry, 193. Okay, that looks better. Okay, and in this case, the first point is at 0. The last point is at 193. But what we can do is, as we will later on create a pattern where I want the point to end here at 90 degrees, I need to reverse the order. Okay, so let's reverse the list so that the first point is not at 0, it's rather at the end number, which is 0.193, and then everything else correspondingly goes to 0, like this. So this way we make sure that, can you see here, that the first point is at, from outside, I mean, is at 0. The next one is slightly higher than that, then the next one, then the next one. So now can you see it follows the same pattern? Okay. So this way I can create a curve that mimics the shape of the pattern, okay, of a single row. How did I calibrate the number? Taking image reference, measuring the object, and then taking pictures, putting it on our CAD context, and then calibrating this number, okay? Again, we think they have used a similar approach. It could be different. It's just for educational purpose to recreate a similar texture. Now, once we have all of these points, let's convert these points into a curve called using a command called interpolate. Okay, so that is the first curve, and we need to create multiple copies of it. Okay, so let me hide the remaining components. Okay, so it mimics a similar shape. And now we need to create a radial set of copies of it. Okay, so in Rhino, you have a command called polar array. Okay, so we can do the same thing in Grasshopper with the same command called polar array. Okay, so the geometry that you want to rotate is this one. What type of input range? Yeah, so basically what happens here is that you're creating a domain between 0 to 193. So instead of constructing this node like this, okay, it's doing the same thing. 0 to 193, sorry, is doing the same thing. It's just that if you create a single number, it creates a domain between 0 and that number. So you don't need to create the domain starting from 0 till here. Earlier, we had to do it because our starting number was not 0. So we didn't want the default behavior of a domain between 0 and 312. We wanted a domain from 34 and 312. Whereas here, just by adding a number, we get a domain from 0 to 0.193. Okay, so that is why we just added a number slider. Okay, so the polar array command. So we need 84 copies. Okay, as you can see, we have all the copies here. Now we actually need the first and the second curve only to create the points, and then we can copy those two curves half of the time of this. So instead of 84, it will be 42. So let me select the first curve only from the list. So in order to select one curve from the list, you will use this command called sets list item. Okay, let me hide the other nodes. So you can see it selects only the first item from the list. So out of the 0 to 83 curves, we are selecting curve number 0 by default, the first curve. And I want to select first and second, so 0 and 1. Okay. Now, rather than making two separate components with 0 and 1, there's a feature in some of the components in Grasshopper, and that is from far away, it seems like there is only one output. But if you zoom in a bit more, you can add additional output. So this is the item number 0. And if I click on plus, it will give me item number 1 as well. Okay, so both of the curves are here. Perfect. So you zoom in and extract one more index. All right, so let me first show you how can you make a set of points on this curve. Okay, so just like earlier, the evaluate curve feature, let me evaluate this curve. Be careful, in order for this command to work, you have to right click and turn on reparametrize. Same here. This curve by default has domain between 0 and some number, 0 to 356. But if you want to convert it between 0 and 1, you have to right click and reparametrize the curve. Okay, so this way I can now create points where 0 is the starting point, 1 is the end point, and any number of points in between on the curve. Okay, now rather than manually making these points, what I can do is create a range of numbers between 0 and 1. So the range component's default domain, default starting and the end number is between 0 and 1. So if you connect it here, you can see that. And you can control how many points you want. Let's say you want to create 88 points. Okay. Now in this case, it's not actually 88 points. It's 1 point, and then the next point is removed, then the third point, and then the next point is removed. Okay. You will also notice that the pattern is not faring well. That is, the pattern is closer to the left side and it's farther away on the right side. Okay, so let me show you how it can also incorporate that feature. First, let me get rid of the access points. So in order to get rid of the alternating points, there is a command called dispatch. So sets list dispatch. Connect the points here. Hide everything. And if you connect a point container at the A output, you can see the alternating points. Okay. So instead of 89 points, now we have 45 points. Okay. 45 points. But you can see the pattern is not spaced as we wish it to. So in order to have a non-linear position of the points, we will use a command called graph mapper. So go to params, input, and there's this command called graph mapper. By default, this command doesn't show you anything. You have to right click on it and then go to graph type and select one of these graphs. Okay. And we will use, let's say, Bezier graph. So remember, when you make a graph mapper tool, right click, choose one graph type, Bezier graph. So these are numbers between 0 and 1. It outputs numbers between 0 and 1. But now pay attention. as you move the graph, you can control the gap between the points. Okay, so here you can more or less position the points around this area, approximately there, and here it's around here. Again, this requires a bit of refinement. You can take your time to further calibrate the shape. Okay, around here. And then this one is maybe around here. Yeah, more or less. Okay. Don't worry, I have shared you the finished Grasshopper file so you can calibrate it later on based on that number output. So these are the first set of points. Now for the second set of points is just the same step, but from the one output. So you will evaluate the curve. Remember to reparametrize same places to get the same distribution of points. Okay. You will use the same dispatch tool to remove the alternating points, but this time you will use the B output and not the A output to get the opposite set of points from the list. Okay, so now we have the points in its correct position. Finally, we will run the polar array command, okay, where we will combine all of the points. Now, when you want to combine multiple lists into the same input, you have to press Shift. Okay, remember when you used Control, it was removing the cable, but when you press Shift, it adds a new cable to the same input. Okay, so remember to press Shift to connect multiple cables in Grasshopper. Now, in this case, as earlier, our pattern was 84 counts, but now we have 2. So it's a set of 1, 2 becomes 1. So it will be half of the number of count. So instead of 84, we now need 42. Okay, so we have the correct distribution of points based on the pattern. Okay. Let me know if you have any questions. And you can take your time to fine tune these values to control how the pattern fades. Okay, we have a lot of liberty here. Okay. And now the last step is to convert these points into circles. Okay. So first of all, the output that you will get from the polar array component is going to be a list made out of many branches. Okay, which you can see using this cable. Now, these are some advanced stuff, but if you're interested, you can check our courses. I'll talk about it in a moment. All right, so we need to put everything in a single list. So there is a command called flatten. Okay, you're not changing the position of the points. You're just restructuring the list. And now we will make circles on these points. So let's use the circle component. Okay, don't forget to hide the previous nodes. What was the modification to the range parameter to make the points arced? It was not, if you're talking about the first one, it's 0.193. And if you're talking about the second one, we are making 88 points. But these values go through graph mappers. Instead of a linear mapping, we have a slightly curved mapping. But yeah, to make the initial arc, this is the value, 0.193. Okay, so as you can see here, we can make circles on these points, and you can control the radius using a single value, but we need to create an attractor effect. We want to make very small circles in the beginning, and then the circle size increases as we go outwards. Okay, so for this we will be using an attractor workflow. Okay, let me show you how can you make the attractor workflow. Okay, so first of all, we need to construct a point at 0, 0, 0. So there is a command called construct point at 0, 0, 0. Let's measure the distance between the grid points and the center point. Okay, so it gives us a set of numbers, and we can multiply the number, because if we use the raw number, it's going to be a lot. But if I multiply the number with another smaller number, we can control the radius value. I think 0.050, something like that, like a very small number. As you can see, this is a simple attractor effect. Okay, the problem here is that we don't have a precise control, but I have shared you a file where you can see how to get that precise control. I'll quickly show you here. So instead of just multiplying the value, what you do is called remap number. Okay, so you remap the numbers coming out from the distance component. You need to know the lowest and the highest number in your list that you can see using the bounds output. So 34 to 312, more or less the same value we set up in the initial part. And then you construct a domain to tell what is the lowest and the highest desired radius value. So the lowest is 0.65 and the highest is 6 millimeters. And the values connected here. Okay, so the lowest circle's radius is 0.65 and the highest circle's radius is 6 millimeters. So this way you have an exact design for manufacturing number for manufacturing part. Okay, so these are the circles. Okay, now the next step is to so we have some questions. What about the scale of the circles? Graph mapper again? No, I mean, we use the attractor effect, but yeah, you can also add a graph mapper in between to further create a nonlinear fading of the radius value if you need to. What was modification to the range parameter to make the points arced? Okay, I have explained that. Wouldn't it be better to make circles along the two curves first and then make the polar array instead of dealing with data tree? No, not necessarily. Like even if you make the set of circles here, the problem is in this step, as the two lists are coming in from different branch paths, when they merge, you get a single, like you get multiple lists, single list. Anyways, just a sec. Can you all hear me properly? I think I moved my microphone slightly. Anyways, yeah, going back to the example. So the pattern is laying flat on the ground. Okay. And we need to rotate it 90 degrees because our geometry, if you unhide the next layer called Grasshopper, and all the remaining geometries that we made earlier, they are all laying in the X and Z plane. Okay. So same here. Let me rotate the pattern 90 degrees. Right? So to rotate the pattern, you would use a command called orient. Okay, just like earlier we saw. But in this case, you orient these circles, okay, from the base plane, which is the global X and Y plane, to the target plane, which in this case is X and Z plane. So just write X, Z. You will see this component called X, Z plane, and we can connect it here. And now you can see the pattern is rotated 90 degrees. Let me hide this. Okay, so far we have managed to make the 2D pattern using points. Use the points to make the nonlinear distribution of the points along the curve. And then we have also used the attractor effect to change the minimum and the maximum radius. Okay, and finally we have rotated it 90 degrees, so only in the target input. A lot of the components in Grasshopper, you need to remember, they already have predefined inputs. You can hover the cursor and see that. So that is the advantage of a lot of the components in Grasshopper, that you don't need to provide each and every input manually. Here, the base plane, the source plane, is already the global X and Y axis. Of course, if it was somewhere else, you need to input that, but generally you model geometries around 0, 0, 0. So a lot of the components are optimized to be used at 0, 0, 0. Mirror, yeah, you can also do that, but the problem is that even if you mirror it, it could work. I'm not sure. It could work. Let me see if I can share you a mirrored part. Okay, so yeah, we can technically see the exact intersection. Yeah, it could also be made in that manner, but you can see here that in the actual product, because I have it with me, the points around the center are way closer than the outside. So I'm not sure if exactly it will fare the same manner. Okay, that is the reason I think this is not done using the mirror command. But yeah, good question. Okay, now let's go to the next part, which is creating the 3D pattern. All right, so to make the 3D pattern, we just have to extrude these geometries in the y-axis. First of all, let's convert these curves into surfaces. To do that, you just pass the curves, the circles, through the surface container. Okay, there we go. And we will extrude. So surface, freeform, extrude the surfaces in the y-axis by 100 units. Okay, I'll just extrude it way beyond. Okay, and we need to solve for Boolean intersection between the two models. Now, you can do this operation in Grasshopper or you can do it in Rhino. In Rhino, it's a bit faster, okay, compared to Grasshopper. But again, it's up to you. Okay, if you want to automate the process, you can do it directly in Grasshopper. So what I will recommend you all to do is drag and drop the third Grasshopper file in your Grasshopper canvas in the same Rhino file, okay? So that you can see the effect. So this is the end result. I have annotated all the steps one by one. You can see it's exactly the same thing. It's just that at the end, I am extracting all the objects. You can start with a smaller number. Okay, let's say just this, so that I can see what it is going to do. And then turn on this component. Okay, be careful if you turn it on without selecting the 200 option. It can take 2 to 3 minutes. So basically these are the intersected parts. Okay, we could have also extruded the geometries in in Rhino. Okay. And then perform Boolean intersection in Rhino. So it's a bit faster. Solid operations, Boolean intersection between this and this geometry. So it's going to give us the remained intersecting parts. Okay. So once all of this is done, you can go to this next layer called assembly. Okay, let's unhide that. It might take a while because we have all the final parts there. Okay, there we go. And we need to move these intersected objects by maybe 20,000 units. Let me do a rough calculation. Around, yeah, 23,000 units. Okay, or 500 more. Yeah. So as you can see, I have already copied these objects. I have also created a set of curves, extracted it manually because you need to see the reference image. And we will use this for creating the holes for the screws and for the speaker. Okay, so you can use the same line cut option. These are the intersected parts that I showed you earlier. And the only thing that I'm doing different here is that I'm moving the object to provide the thickness. I'm moving it by 1.5 units. Okay, and finally we can perform Boolean difference. Could you make each of the holes oriented perpendicular to the curvature of the surface? Yes, you can do that. But for that, you need a bit more advanced operation. And that is something precisely we also teach in our advanced parametric texture workshop, how to make your designs. For example, in this case, we need demolding angle. Apart from that, we also want the perforations, let's say, in the normal direction while maintaining the demolding angle. Okay, so those things are a bit more advanced operations, and we cover that in our advanced texture workshop. Anyways, so in this case, you can perform Boolean difference. I never recommend you to perform Boolean difference for all the cutouts simultaneously. It's better you ungroup it and perform Boolean difference in batches. So Boolean difference, I'll select a couple of objects and then perform Boolean difference. And then I will rerun it and select next set of perforations. Okay, so like this, you can apply the operations in 10, 15 steps. If there is any error, you can also troubleshoot it. Whilst if you try to do this all together, it might take a while, and in Grasshopper, it might even crash your computer. Anyway, so I have already done these operations for you, which is this end result. Okay, so we have the set of perforations for the screws, we have the pattern itself, we have the backside, we have the base cover, we have the leg assembly and the cable cap and the 3 legs. Okay, so these are all the files or all the 3D models that we need for making the render. Okay, let me know if you have any questions before we head to the next section on how to create the renders. Let me see some questions from earlier. Okay, yeah, be careful with this tool, because if you add all the 4,000 objects, it will get stuck for 2-3 minutes, depending on how fast your computer is. All right, so meanwhile you're writing your questions, let me explain you the next part, which is how to make the render in Keyshot. Okay, Now, for Keyshot, we also have a course for beginner intermediate users called Keyshot Rendering Masterclass. So here, if you are using Keyshot for making product visualization, you can check this one out. We start with, how to make PBR textures, how to create physical and HDRI lighting, part and camera animation, perspective matching, procedural textures, okay, how to render glass and liquid materials, okay. You can check some of the students' portfolio on our webpage. So this is from our Keyshot rendering masterclass. All right, so now let's go to the next section, which is creating the renders. All right, for renders, I will be using Keyshot. Okay, so just double click on the fourth file. It's going to open your Keyshot environment. Okay, now in this particular example, I have already configured the lighting and the position of the object. Okay, and I have made some cameras to see the material and the composition from different angles. Okay, so this is the end section that you see in our CAD file here. Okay, so you will select all of these, export them as Rhino file, and then import it in Keyshot. Okay, now we are used to either selecting materials from the existing library. Let's say I want to apply a plastic material here. So you can drag and drop it here, right? Or you can make your own custom materials by using one of these web pages. For example, Polygon, okay, or Texture Haven, or similar tools or pages like this. The problem here is you need to first download the images, and then you need to align these maps properly. You need to configure the material from scratch. Okay, and it can take a while. And if you don't know how to do it properly, because these web pages, they supply materials for all different rendering engines. So if you don't know how to configure it properly for Keyshot, even after paying for these textures, you will not get the best results. Okay, so what I will recommend you all to do is give this particular service a try. Okay, it's called Vision, and they have collaborated with us in this webinar. Okay, and they are a supplier for materials, scenes, and texture for Keyshot specifically. Okay, and what I really like about these textures, because I'm using these textures on my day-to-day projects, as well as some of the renders you see for the student portfolio, they are optimized for industrial design. So they have the common materials that you would need as an industrial designer. So let's say you're designing furniture, so you have all the different wooden material, consumer tech fabric, you have metallic materials, and they also had a pack for 3D printed objects. Okay, so if you want to mimic a 3D printed effect, you can also check these ones out. Anyways, so with the download folder, you will see a set of materials supplied for a Vision. Let's unzip the files. Okay, and let me show you how easy it is to import a material and apply it in Keyshot using this service. Okay, so these files are special files called KMP. Okay, you go to your Keyshot environment. In the library tab, click on material, and let's add a new folder. Let's call it vision.io. Okay, so now I have an empty folder called vision.io, and now select that folder and import the files. So I will click onto the download folder and import these 4 KMV files. And now you can see we have imported all the files here. Okay, all the materials here. And you just need to drag and drop and use these for your product. For example, I will use the plastic for the main part, texture part. So let's drag and drop it there, and there we go. Okay, so it has a high quality set of textures inside. Some of them are made with procedural textures, and you can double click and calibrate it as per your requirement. Use one of these cameras to see at the texture from a closer distance. Now, let's say you want to use the aluminum material for the rim. So you just need to drag and drop it there. Or also for the screws. Or also for the legs. Okay. If you want to further edit this material, you just have to double click on it. Okay, and you can change properties of this material. Let's say I will add a bit more roughness, 0.35 instead of 0.15. Okay, it's a bit more sandblasted effect. For the back side, you will use the molded plastic. Just drag and drop it here. Again, you can see it's a very nice looking high quality pattern. You can double click and further edit the material. So imagine in this case, we need to increase the size of the pattern. You can double click on this node and maybe make it 300 by 300 or 1000 by 1000. Okay, so you can control the size of the pattern. It's a microscopic texture, so you might have to increase the size a bit more. I think in our case 1500 looks about right. Maybe 1000 is better. Yeah, that looks nice. All right, so as you can see, just by dragging and dropping some of these materials, we are creating a high quality production ready renders, okay, for our portfolio, for our web page, for our services. Okay, so you can use these different cameras to create the composition and then render these outputs. Okay. All right, so let's see some of the questions. Meanwhile, you add more questions related to Keyshot. Someone is asking, how do you render those EMAP prototype like renders in Keyshot? I'm not sure. I mean, I'm using either Keyshot or I'm either using like EMAP and then combining it in Figma or something, like stacking on top of each other. Maybe is that what you're asking? But yeah, I'm primarily using Keyshot to make renders, and the materials I'm using is either from Vision or I'm using the default set of library. I saw some experiment you did with the Grasshopper making a ripple effect on the same object. Yeah, that is kind of like an advanced workflow, and we don't cover exactly that texture, but we cover the same technique in our advanced parametric texture workshop. Okay, I'll explain about that just in a moment. Slotted pattern on the base cover. It's using Grasshopper. I'll show you. I'll try to find the script and show you in a moment. I mean, those student portfolio renders, it looks awesome. Yeah, it's all done in Keyshot. Some of it is done by the students and some of it is done by us, because primarily they are submitting the projects not for Keyshot, but for Grasshopper or Rhino. So yeah, we try to render and present the concept in a more visually appealing way. All right, so before you see more things, let me explain you that you can share these projects with with your audience, with in your online portfolio, in LinkedIn, in social media. But we will really appreciate if you can tag us on your posts or provide us credit, because we have seen in the past people just take these files and they upload it as if it was theirs. So we will really appreciate if you can tag us and mention us in those posts. Okay. With that saying, we have two advanced courses. One is the Advanced Parametric Texture Workshop. So in this one, you will learn how to make the textures that we just saw, but make them first manufacturable. So we will incorporate all the design for manufacturing criterias. But the texture that we just saw was a very simple example of texture workflow. Here you will learn way more complex workflows, like how to fade patterns with G0, G1, G2 continuity, or how can you create like these kind of draping patterns or ripple patterns or patterns on poly surfaces. So a geometry made out of many surfaces, how can you apply a texture there? Okay. These are some of the projects from our texture workshop students. For example, this one, like how can you make fading patterns on products? Okay. All right. This is the end result as a 3D printed object of the design that we just made. Okay. So in this one, I incorporated some design for manufacturing criteria, like adding the demolding angle, um, which is something we teach in the advanced workshop. Okay, so the data you generate in Rhino and Grasshopper is NURBS data, and it can easily be incorporated into the design for manufacturing pipeline. Lastly, we have the computational design workshop. So if you are using Grasshopper to make lattice structures, generative design, data-driven design workflows, you can check this one out. Okay, so here you will learn how to use topology optimization to make parts lightweight, generative design to explore ideas, dendro and voxel modeling workflows to make lattice structures that can be easily 3D printed. Okay, you can check this one out. So here are some of the portfolio projects from the computational design workshop. Okay. Lastly, we offer training for your teams. So if you are working in a design studio and you would like to learn how to apply these workflows on your own projects, you can contact us and request a team training for your company. Okay. These other courses, they are during the weekends, whereas the team training can be delivered on the weekdays. All right. We can also make custom bespoke curriculum to tackle specific questions. Okay. Apart from that, you can check our website and see the past portfolios of projects from students from different courses. You can also check our past webinars. Okay, so you can start with this one and you can see the other ones from the past, like how to make this fading pattern. Okay, and you can also check our calendar tab for the next course dates. Okay, so you can check it here on our calendar page. Apart from that, we keep on adding new learning resources, so you can check this section out. We have around 40-50 articles, including some tutorials and downloadable files, okay, that you can use to further learn Rhino and Grasshopper. Okay, let me see if you have any questions. Thank you. Amazing webinar. The recording will be available like after the webinar ends using the same YouTube link. When I create a surface with arc and then use duo face border to draw the surface lines, why are there so many control points? Do you know why? Yeah, I mean, whenever you have a surface that you trim, let me show you, you end up rebuilding the boundary within file tolerance. Okay. So based on the file tolerance, which generally is 1,000th of a millimeter, you recreate that border with those many control points of a degree 3 curve. So that is why the edge is plus and minus 1,000th of a millimeter, okay, of that mathematical edge. And that is why it's made out of so many control points when you run dupe edge or dupe face border. Can't wait to be an official student on Academy. Yeah. Let us know if you have any questions regarding our courses. You can reach out to me or to Estella, and we will help you with your doubts. Okay, let me know if you have more questions. All right. Yeah, so I think you have all the resources at your hand. Okay, you have all the download files here. If you want to see the end results of the Keyshot, you can also double click and just see the end result. You also have the Fibonacci Grasshopper file if you want to just see the basic 2D pattern. Okay. So use these files to make your own variations of textures, and let us know. Tag us on our social media, and we will repost these projects that you make. How long does it take to master Rhino? Depends on how many hours you use every day and what kind of products you're modeling when you're using Rhino. Because if you are modeling something very basic in your work, you don't need a lot of time. Maybe 6 months to a year. Of course, if you have a good foundation, and that is one of our goals in our Rhino masterclass. Like, we explain you what is a surface is irrespective of Rhino, Fusion, CATIA, SolidWorks. So once you have a good understanding of geometry, NURBS geometry in this case, everything else becomes a lot easier. Okay. So once you have these foundations and then what you want to design, it can take 6 months to a year for some simpler, like, shapes like solid modeling. But if you are into high quality surface class A modeling, it can take 3 to 5 years of daily use. Okay. So depending on how many hours you use, how many different type of problems you deal with on a regular basis, you will need a range of 6 months to 3-4 years. Um, did the advanced Grasshopper course show how to dominate the data list and create specific tailor-made texture? In our Grasshopper master class, we tackle the problem of data tree and list management. Just a sec. Let me close this. Okay, so here you will learn how to create lists, how, like, what is graph, what is flatten. So you will understand how data hierarchy is matched and everything in the Grasshopper masterclass. Whereas the texture workshop only focuses on making textures. We see around 14 different strategies to make patterns, like how to demold the parts for manufacturing, how to drape a texture on a complex poly surface. Okay. You do need experience in Grasshopper to join our advanced courses. So the texture workshop and the computational design workshop, these are advanced courses. Okay. So if you have never used Grasshopper, or you have used but you don't understand data tree and list management, I will highly recommend you to start from this one. Okay. Thank you, Day, for your comments. Yeah, let us know if you have any questions, and good luck to you all with your design projects. Okay. Um, and yeah, do let us know over email or in any of our posts, what would you like to learn in the next webinar? This video is also going to be in YouTube later on, so anybody who's watching afterwards, if you can write down what could be the next product that you want to see, we might try to include that for webinar 10. But yeah, if you want to incorporate textures on your automotive design parts, then yes, you can combine Alias with Grasshopper. We even wrote an article back in the day, like how can you export models from Alias to Grasshopper to apply patterns on your Alias parts, and then export it back and incorporate it back on your Alias model. Okay. Yeah, so with that said, let's stop here. Thank you all for joining. Good luck with your upcoming projects, and talk to you guys in the next webinar. All right. Bye-bye. Take care.